Namaskar friends. In today's video also we shall discuss about some of the not so familiar rules for finding integrating factors. Now these rules which we shall discuss in today's class will not be available in common texts. So let us start today's video to see those rules, what are those rules and how to find out the integrating factor using these rules. Let us start today's video. Now this is the first uncommon rule of today's video. It says that if 1 by mx minus ny into del n del x minus del m del y equal to some function of xy. Okay, it is not function of x comma y. Function of x comma y means a function of two variables x and y, where x and y have no bound that x and y should come together like that. But over here it is a function of xy, x into y. So wherever you will have find x, you will have a y for it. For example, x square y square plus xy plus tan xy. See, this one is nothing but xy whole square. Okay, this one. So you have xy whole square plus xy plus tan xy. X and y are coming together in pairs. So that's why you can tell this is a function of xy. But if I just put over here y square, or suppose I put over here y cube, so here an extra y comes, here an extra y comes. Same thing for x also. So this will not remain a function of xy. Function of xy means x and y will come in pairs in product form. Okay, so this will be a function of xy. Then the integrating factor will be e to the power integration of this function with respect to xy. Okay, so this is the rule that we shall see first in today's video. So the example is x to the power 4 into y square minus y dx plus x square into y to the power 4 minus x dy equal to 0. Now over here this rule will be applicable to this problem. Now one question comes in the mind of students that how shall we understand which rule is applicable to which problem? You know, there is no certain rule and regulation that will guide you that okay, this problem will be applicable to this rule, or this rule, rather to say this rule will be applicable to this problem. It's just my mere experience, intuition and trial and error that you have to understand that which rule will be applicable to which problem. But first of all, the thing is that you have to test whether actually this given equation is non-exact or not. Who knows? The given equation, if it becomes exact, then no question of finding an integrating factor. So the first thing that I told before also, you have to test whether the given problem is non-exact or not. What is the testing procedure? It is that you have to find out del m del y equal to del n del x or not. Now this is m and this is n. So what will be del m del y with respect to y? That is 2 x to the power 4 y minus 1. And what is del n del x? See, del n del x will be 2 x y to the power 4 minus 1. Now see, these two are obviously unequal, so the given equation is non-exact. Now obviously there will be an integrating factor and this rule will be applicable to this problem. This is by mere intuition that we have to understand, or by experience or trial and error method that you have to understand that which rule will be applicable to which problem or not. Now see, if this rule is applicable to this problem, you have to find out this. Firstly, 1 by mx minus ny, which is equal to this one into x. So it will be x to the power 5 y square minus xy minus ny. So x square y to the power 5 plus xy. So xy gets cancelled out. Now if you take x square y square common, what do you have? X cube minus y cube. So you're getting x cube minus y cube into x square y square over here. So we have got these three expressions. Now we have to combine these three expressions into this. Therefore, 1 by mx minus ny into del n del x minus del m del y. Let us see what it comes, which is equal to 1 by x square y square into x cube minus y cube into del n del x minus del m del y. So 2xy to the power 4 minus 1 minus 2x to the power 4y plus 1. So 1 gets cancelled out, and you can take xy common from here, 2xy, that is equal to 2xy by x square y square into x cube minus y cube into what remains, y cube minus x cube. So ultimately, if you cancel out all this, what remains? Minus 1, that is equal to minus of 2 by xy. So this expression you are getting ultimately minus of 2 by xy. Obviously, since xy is coming in pairs in product form, so this is a function of xy only. So this rule will be applicable, and the integrating factor will be e to the power integration of this expression with respect to xy. So the integrating factor will be e to the power integration of minus 2 by xy with respect to xy. That is equal to, now we all know this is e to the power minus 2 ln xy. Now that is equal to e to the power ln xy to the power minus 2, which is nothing but xy to the power minus 2, that is 1 by x square y square. So the integrating factor is 1 by x square y square. And what you have to do with the integrating factor? You have to multiply this integrating factor into the original equation and then solve it. Now you all know the analytical method also and the shortcut method also. We discussed those methods in my previous videos. You can go to those videos and see what those methods are. Very easy methods. It is my request to all the viewers, please solve this problem by multiplying the integrating factor into the original equation and let me know the answer in the comment section. Now this is the next rule. It says that x square divided by mx plus ny into del n del x minus del m del y, if this expression is a function of y by x. Now previously, in the previous rule, it was saying that whatever we had in the left hand side, the outcome will be some function of xy. Over here, the outcome will be some function of y by x. That means the expression that will come over here, the terms will be in the form of y by x. Means y by x will be together. Okay. For example, y square by x square plus sine y by x plus 1. See over here, this is actually y by x whole square. So this expression is a function of y by x. But if I put something over here, suppose x square or y square, it does not remain a function of y by x because offbeat term of x square over here, this you cannot tell it is some expression of y by x. Okay, so over here the functions will be like this. Whatever you will have over here, the terms will have y by x only. Some types of y by x whole square, y by x whole cube, okay, sine of y by x, cos of y by x, and so on. Anyways, so if this expression is a function of y by x, then the integrating factor will be e to the power integration of that function of y by x with respect to y by x. So this is the next rule. Let us see one problem and let us see the demonstration of how this rule actually acts. So the given problem is 2x square by y plus x by y dx plus 2x dy equal to 0. First thing what to do, you have to test whether this given equation is exact or not. This is m and this is n. So del m del y, this one with respect to y, it will be minus 2 x square by y square minus x by y square, and del n del x, this is 2. Obviously these two are unequal. Since these two are unequal, so the given equation is non-exact. Now what to do? We have already know that this rule will be applicable to this problem. So let us just jump into this rule and put the values in these expressions. Okay, and let us see what happens. So let us find out this. You have x square divided by mx plus ny, m into x. So 2x cube by y plus x square by y plus ny, n into y, 2xy into del n del x minus del m del y. Del n del x, what did we get? 2 minus del m del y, this one, minus of this, that means plus 2x square by y square plus x by y square. Now let us solve this. So if you take xy common in the denominator, what you get? Take xy common over here. So over here you have 2x square by y square plus x by y square plus 2. Same thing you have over here, 2 plus 2x square by y square plus x by y square. See, same thing. So these two gets cancelled out, and what remains over here? X by y remains. So you can tell this is equal to x by y. Now what happens? The function should have been, this left hand side should have been an expression of y by x. Instead it came x by y. Is there any wrong over here? No. See, this can be written as equal to 1 by y by x. So ultimately you are getting this expression as a function of y by x over here. Now if you get this as an expression of y by x, the integrating factor will be e to the power integration of this with respect to y by x. So let us find out what the integrating factor will be. So the integrating factor will be e to the power integration of 1 by y by x d of y by x, that is equal to e to the power ln y by x, which is equal to y by x. You have to multiply this integrating factor in this equation and then solve. Now there is a counterpart to this rule. It's just that over here you had x square by mx plus ny into del n del x minus del m del y equal to some function of y by x. Here at the numerator you will have y square. Instead of x square you will have y square, and this will just get reversed. Over here you had del n del x minus del m del y. Over here you will have del m del y minus del n del x, and the outcome will be a function of not y by x but x by y. The integrating factor will be same, that is e to the power integration of this. Since over here you have function of x by y, so the integrating factor will have integration of function of x by y with respect to x by y. This is just the difference. My dear friends, this is all what we had for today's video. If you have learned something new in this video, then do share this video with your friends, like my video, follow my page and subscribe to my channel. Till then, goodbye.